Hey everybody, thanks for joining me today. Let's get going here. We're talking about real numbers, and in this unit, one of the biggest keys is learning about radicals and square roots. Whenever you see a radical symbol, hopefully you've already gone over this. If not, this is a great time to talk about it. Whenever you see a radical symbol, it is referring to only the positive square root, which actually makes things really easy on questions like number 1. What is radical 64? Well, you just ask yourself, what is the positive square root of 64? And that looks to me a lot like 8. See, there you go. That's all it takes. Now, whenever you see something like a 38, this is where it gets a little bit more complicated because 38 is not a perfect square. That means you need to actually probably break out a calculator. Now, we could estimate it and figure out, well, since the square root of 36 is 6, that means the square root of 38 is going to be something just a little bit bigger. And that's true. That's a good way of thinking about it. But in this case, it said 3 decimal places. And doing that to 3 decimal places in your head would be pretty difficult. So we'll just move on to the next one and take the calculator response here. Whenever you're talking about a fraction, all you have to do is take the positive square root of the top, the positive square root of the bottom, and get it done. So in this case, I'm just going to call it 7 over 12. That seems pretty good to me. We do want to check and make sure that it doesn't reduce. In this case, 7 over 12 does not, so we can move on. All right, let's break out 111, and 121 is a perfect square. 111 is not, so I'm just going to go back to the calculator. Now, just looking at it off the top of my head, I'm going to guess it's right about 10.5, 10.6 in that ballpark. And that's because I was able to figure out 2 perfect squares that were nearby. Let's go with 10.536. If we're going to go 3 decimal places like the directions say, we're going to call it 10.536. There you go. All right, now, example 5 is one that I feel like eventually will be good to memorize. This probably isn't something you just look at and know right away, although some of you might. Eventually, at some point, I think it'd be a really good idea for you to know these. Not necessarily all of the big number radicals, but certainly something like 900. 3 times 3 is 9. 30 times 30 is 900, so it works out pretty well. All right, we've already done one of these fractions, so another one shouldn't be too hard. That looks to me like those are both perfect squares, and we can just call it 5 over 8. It does not reduce, so we'll move on. All right, radical 63. Now this one, you will eventually learn how to simplify a radical. Some of you may already know how to break it down into smaller radicals. But according to the directions, it says if your answer is irrational, calculate it to 3 places. Now 64 is a perfect square, 63 is not. It's really close though. So that means what, 7.9? 7.95? I don't know, I'm just going off the top of my head. 7.937, we'll go with that. 7.937. All right. Now this one, you have to take the square root of 7, the positive square root of 7, so radical 7. And then there's a 3 in front. We got to multiply it by 3. So your calculator will do that as well. It's not really that big of a deal. You'll get 7. Wait a second. It's the exact same answer as the last one. And I did that on purpose. It's not meant to be a surprise to your teacher, probably. They probably saw it coming. Maybe you did too. But it turns out that this is another way of writing radical 63. So that'll be something in this particular Algebra 1 book that I'm working off of personally. I think this is like chapter 11 or chapter 12 or something like that. But it is interesting to find out that radical 63 and 3 times radical 7 are the same thing. Well, it was interesting to me anyway. All right. Looks to me here, we could either reduce this now or we could reduce this later. I don't really care which one you do, but at some point it is going to have to be reduced. So If you want to wait until later, that's fine. Maybe you already noticed that radical 144 is 12, and that's true. Maybe you noticed what 1 million breaks down to. Hopefully you noticed this. It's just a bunch of zeros added here. 1,000 times 1,000 happens to be 1,000,000. So that means radical 1 million is 1,000. Now, at this point, I'm looking, and I told you already, we either have to reduce now or we have to reduce later. We chose to reduce later. That means this will not do. I am not okay with this being your final answer. We need to reduce. If you cut the top in half and you cut the bottom in half, you're going to find out that it is 6/500. And that is still not good enough because we could cut it in half one more time. So when it was all said and done, what you should end up finding out is that this would reduce all the way to 3/250. So it did turn out to be rational. It was not irrational. It did turn out to be 3/250. Now, if you had reduced first, then you would have eventually ended up with, I believe, 9 on top and 62,500 on bottom. And that seems pretty crazy, but when you do the square root, you would end up getting the same answer. All right, now 1/7 is rational. But if I try to take the square root of it, that's not going to be rational. Radical 7 is irrational. 7 is not a perfect square. So I think the best way to go here is going to be to break out a calculator. And 1/7 is going to be about 0.14285, yada, yada, yada. If we take the square root of that number and then round the way we are told to round to 3 decimal places, we are going to get 0.378. So make sure we round it correctly here. 0.378. All right. Let's get into this table right here. Is 5.67 natural? No. Whole? No. An integer? No. It is rational, however, because we could write it as a fraction if we wanted to. So it would be 5 and 67 over 100, or you could make it improper. You could say 567 over 100. It's all the same. Now, since it is rational, it is not irrational, but it is real. We can cut to the chase on that. These are all going to be real. Now, when you see a ... it's kind of the English ellipsis thing when you're in an English class. That means it's going to go on and on forever, and we don't know which direction it's going, which means that one is going to be irrational. 56 divided by 7 is just 8, and 8 would be all of these things. All right, last but not least, place these on a number line. Hopefully you have an idea that pi is something in the ballpark of 3.14. Hopefully someone has told you that before. If not, then you could look it up on your calculator, but pi is going to go right about there. 7 divided by 2. 7 divided by 2 is 3.5. So that means we need to put it as close to directly in between 3 and 4 as we can. I think right there would be just fine. 19 divided by 5, that's going to be 3.8. It's 3 4/5, so 3.8. So that's going to be more toward this end of the spectrum right here. I think I have room to write that. And then the last one, we have to throw in a radical here just to challenge you. You end up getting the radical of 100 on top, which is going to be 10. And the radical of 9 on bottom, which is going to be 3, and 10 over 3. If you were to type that into your calculator, you might know this is coming, you might not, I'm not sure. You would end up getting that. So it is a repeating decimal, 3.333, yada, yada, yada. And so that's going to be 1/3 of the way along between 3 and 4. So that's going to put you right about there. All right, I hope that helps you get started. Good luck the rest of the way.